Okay, maximization problem. When the elements of the transportation table represents the profits instead of cost. When the elements of the transportation table represent the profits instead of cost, the objective is to maximize instead of minimize. To solve this such type of transportation problem, we need to transform from the profits to the relative cost. This is done by subtracting all the elements from the largest element in the matrix. So first we need to identify which is the largest element in the matrix, and we need to subtract all the elements in that largest number. Likewise, we can convert from maximization into minimization. Once if we convert from maximization into minimization, then we can proceed with the same procedure what we learned now. And we need to remember the formula. So that is a profit equal to sales price minus of production cost, transportation cost, material cost, or packing cost, or anything, any cost. That is sales price minus of cost will give the profit. See, here they are given on problem that is a firm produces a component and distributes them to a 5 wholesalers at a fixed price of ₹10 per unit. Sales forecast indicates that monthly demand is 3,000, 3,000, 5,000 and 4,000 units at wholesale dealers A, B, C, D and E respectively. The monthly production capacity is of 5,000 and 10,000 at plants A, B and C respectively. The unit transportation cost in rupees between the plants and wholesalers are given in the following table. Determine the transportation schedule between plants and wholesalers in order to maximize the total profit per month. Use NWCM to obtain the IBFS. Okay, that last statement is, so in this problem they are given that you need to use the NWCM. If they are not mentioned, then you can go for either NWCM, LCM or VAM. Okay, once if we get the transportation cost matrix, then we need to check the, okay, in the second line they are given that wholesalers that they are selling the product at 10 rupees. They are selling the product at 10 rupees each. But all the wholesalers they are selling at rupees 10. Okay, 10 in the sense, so for 10 minus of that is 10 itself is the profit. Sorry, sales price. Sales price minus of cost will give the profit. For that, in the next one, so we need to write the profit equal to sales price minus of transportation cost. So this is the matrix you need to write down. So 10 minus of 0.5. So likewise, so once if you write that one, so then you will get the answer, this profit matrix. Once if you get the profit matrix, so profit matrix itself is the maximization matrix. Okay, once if you get the maximization matrix, then we need to convert the maximization matrix into minimization by identifying the highest number in the element, highest number in the matrix, and subtract all the elements in that. What is the highest number in this matrix? The highest number is 9.5. If there are three 9.5, it's okay, no problem. But what is the highest number? 9.5 is the highest number. Subtract all the elements in that 9.5 and then convert it to minimization. This is the maximization matrix. I have written there again, and 9.5 is the highest number. Okay, here, so how to convert that? Identify the highest profit in the matrix, subtract all the cell values individually in the highest profit. After that, for the converted matrix can be solved with the usual method, IBFS and MODI. At the end, it is very important for finding the profit. We are supposed to use the profit matrix only. Okay, now I have written the calculation here again, 9.5 minus of 9.5. So this 9.5 is the highest number. So highest number minus of that whatever the number given in the matrix that we need to deduct. Okay, this is the minimization matrix. This is the minimization matrix. This is the way we need to convert from maximization into minimization. Once if we convert the maximization into minimization, then we can go for the finding the IBFS. This problem they are concentrated on so they are given the question that is we need to get the answer by using the NWCM. Okay, this problem is solved by using the NWCM method. This is the way we need to solve the that maximization problem. Okay, once if we get all the allocations like 3,000 to whatever the numbers, once we get the allocations, then do not find the transportation cost with this matrix only, because this matrix is a minimization matrix, but we are solving the problem on maximization. For that, you need to take those values to the maximization matrix, that is the profit matrix. Just write all the allocations in the profit matrix and get the total profit here. Get the total profit here. So this is the way we need to solve the maximization transportation problem. Thank you.